maximum minimum. Suppose this is a curve of fx. Now, if you draw line parallel to x-axis from different points of on the curve, then in this part, this angle is acute angle. In this part, this is acute angle, acute angle. But at this point, tangent is parallel to x-axis. The curve makes acute angle with the positive direction of x-axis. That signifies dy dx greater than 0. So, in this region, dy dx greater than 0. But at this point, dy dx, that is slope of the curve, is equal to 0. After crossing this point, if we draw a line parallel to x-axis from these points, these angles are obtuse angled. Okay. So, tan theta is negative in second quadrant, that is between 90 and 180. Therefore, dy dx less than 0. So, slope of the curve is negative. And from the trend of the curve, it is clear that value of y, that is fx, decreases with increase of x. When x increases, fx decreases. That means dy is negative when dx is positive. Dy, that is increment of y, is negative when dx, that is increment of x, is positive. But in that case, y is gradually increases with the increase of x. That means both dy and dx are positive. Hence, dy dx is greater than 0. Again, we reach to a point where dy dx is equal to 0. Okay. And after that, curve changes its mode. Again, we will get acute angle when we draw line parallel to x-axis. So, dy dx again greater than 0, that is increasing. These points where dy dx is equal to 0, these points are called critical point or stationary point. Between two consecutive critical points, curve remain monotonic. That means it never change its tendency between two consecutive critical points. Okay. And this is the maximum value and minimum value. So, from maximum value to minimum value, fx is decreasing in this region. Now, if you observe these angles, you will find that, suppose this is curve is like this, This is one of the trough, that is where dy dx is 0. The angle between the positive direction of x-axis and the tangent is at initial stage gradually increases. This angle is less than this angle. At certain point, after a certain point, it again decreases. Angle is decreasing and reaches to 0. From 0 to 0, this is dy dx is equal to 0 at this point, and here also dy dx is equal to 0. First, angle increases, then decreases to reach that point. So here we will get a point when dy dx change its mode from increasing to decreasing. Dy dx, change of dy dx, that means second order derivative, d2y dx square, d2y dx square will be 0 at this point, because when change is positive, d2y dx square is positive, change is negative, that is decreasing, then d2y dx square is negative. So from positive to negative, it should pass through 0. So somewhere between these two consecutive stationary points, a point where d2y dx square should be equal to 0. Now, if you observe the nature of the curve, in this portion, this is concave in nature. In this portion, this is convex in nature. Again, this is concave in nature. In where curve convex in nature, d2y dx square, that is dy dx decreases, that is d2y dx square in this region, d2y dx square less than 0, where it makes convex curve, and in this region d2y dx square greater than 0, because slope is increasing. In case of maxima minima, first we find f dash x, and equating that f dash x with 0, we will get this point. Suppose this is x1, x2, x3, that are the critical points. We will get x1, x2, x3, these are critical points. But we have to find the maxima and minima. So we know that some critical value will give maximum value, crest, and some critical point will give a trough or value. So in case of trough, that is at the minimum point, d2y dx should be greater than 0, because this is concave in shape. So when it form concave, d2 dx square 0. So after finding f dash x, that critical points, we have to find double derivative of the given function. And by putting this value, if we get when x1 f double dash x greater than 0, that signifies that it is valley or minimum point, minima. If that is minima. And when f double dash x less than 0, that is negative, it will convex in shape. So it will be maxima. Clear? But when it is equal to 0, we have found here d2 by dx square is equal to 0. But in some function we will get d2 by dx square is 0 at the critical point when this x1 and x2 approaches to each other and combines. Then what will be the nature of the curve? Suppose this part, if this part vanishes, then we can add this part at the top like this. This part is concave, this part is convex, and they meet at the critical point. Suppose fx is equal to x cube. This time in this curve, this like this is concave and this is convex, and they meet at critical point. X is equal to 0. So when f double dash x is equal to 0 at some critical point, these points are called point of inflection. Point of inflection. Because we know that tangent never intersect the curve. Tangent only touches the curve. But in this type of point of inflection, tangent intersect the curve, because at this point tangent will be like with intersect this curve. In this problem, fx is equal to 1 by x whole to the power x. So f log of fx is equal to x into log of 1 by x, that is equal to minus x log x. So 1 by fx into f dash x by differentiating log fx minus, when differentiating x we will get 1, and minus x into 1 by x is equal to minus log x minus 1. Now when f dash x is equal to 0, minus log x minus 1 is equal to 0. So log x is equal to minus 1. So e to the power minus 1 is equal to x, or x is equal to 1 by e. again f dash x is equal to fx into minus log x into e, because we can write this as log x plus log e. 1 is equal to log e. So this will be x plus x into e. Now f double dash x is equal to minus f dash x into log xc minus fx into xc into e. So e will be cancelled. Fx by x. Now putting x is equal to 1 by e minus f dash 1 by e log 1 f1 by e by 1 by e. Log 1 is equal to 0 and this will be f1 by e fx is equal to 1 by x whole to the power x. So f1 by e is equal to e to the power 1 by e. Clear? So it is positive. This is also positive. So f dash f double dash 1 by e less than 0. This is only for confirmation test. Just we have to find that whether f dash x at the critical point is less than 0 or greater than 0. Okay. Therefore, fx is maximum at x is equal to 1 by e, and its maximum value will be this is maximum value is equal to e to the power 1 by e. Theta is equal to 2 theta minus sine 2 theta divided by theta square. So f dash theta is equal to theta to the power 4 theta square into 2 minus 2 cos 2 theta minus 2 theta into 2 theta minus sine 2 theta. Therefore, f dash pi by 2 is equal to pi by 2 square into 2 minus 2 into pi cos pi minus 2 into pi by 2 into 2 into pi by 2 minus sine 2 into pi by 2, that is pi. Pi square by 4 and this is 4 minus pi into pi divided by 4 pi square by 4 is equal to pi square minus pi square 0. Okay. So it has critical point at pi by 2. Now f dash theta into theta to the power 4 is equal to theta 2 theta square minus 2 theta cube is equal to 2 theta minus 2 theta minus 2 theta cos 2 theta minus 4 theta plus 2 sin 2 theta. Okay. So f double dash theta into theta cube plus 3 theta square f dash theta is equal to 2 minus 2 into cos 2 theta minus 2 sin 2 theta minus 4 plus 4 cos 2 theta. Now put theta is equal to pi by 2. Pi by 2 whole cube into f dash double dash pi by 2 is equal to 2 minus 2, this is minus 1, minus 2 into pi by 2 into pi 0 minus 4 plus pi 4 into minus 1. This becomes 0, all are negative. 2 minus 2 plus 2, sorry, minus 4 less than 0. Therefore, fx is maximum at x is equal to pi by 4, 2. So that for all rectangles, let length and of the rectangle be x and y respectively. So given perimeter, therefore perimeter P is equal to 2 into x plus y is equal to constant, given that is constant. Square has greatest area. So 1 plus dy dx is equal to 0, differentiating both sides. Dy dx is equal to minus 1. Now the area. Is equal to x into y. So dA dx is equal to y plus x dy dx is equal to y plus x into minus 1 is equal to y minus x. At critical point, dA dx is equal to 0. at critical point, that implies x is equal to y. Now confirmation test. d2y dx square is equal to dy dx minus 1, dy dx is equal to minus 1 and minus 1 is equal to minus 2 less than 0. Therefore, A is maximum when x is equal to y, that is length is equal to breadth. Hence, it is a square. So, square has its maximum area when perimeter is given. Find the dimensions of the rectangle of maximum perimeter. So, we have to maximize the perimeter of the rectangle that can be inscribed in a circle of radius A. Okay. So, rectangle inscribed in a if we join these two, this is a rectangle, the rectangle. Radius is A. So, which one is radius? This is the radius. This is A. We know that in rectangle, diagonals are equal. So, we can say that this is also A. Let x and y be the length and breadth of the rectangle. So, we can say that x square plus y square is equal to 2a whole square is equal to 4a square. 2x plus 2y dy dx is equal to 0 since this is constant. So, dy dx is equal to minus x by y. Now, we have to maximize the perimeter. Maximize the perimeter. So, P is equal to 2 into x plus y, dp dx 2 1 plus dy dx is equal to 2 into x by y is equal to 2 into y minus x by y. At critical point, dp dx is equal to 0. At critical point, so 2 into y minus x divided by y is equal to 0. That implies y is equal to x. So, we can say that this will be square. Now, we have to confirm whether it is maximum at this condition or minimum. Now, the second order derivative, that is p double dash is equal to 2 y square y into differentiation of y dy dx minus 1 minus differentiation of denominator dy dx into numerator. Now, if we put x is equal to y and 2 into y and this is minus y by x, x by y, sorry, minus dy dx. So if you put y is equal to x, this becomes 0 and this become minus 2. So this will be less than 0. Y and x is positive. So we can say that y is positive, this is negative, and this 0. So it will be less than 0. Therefore, P is maximum when x is equal to y. That is, rectangle is a square. Y square is equal to 2px, which is nearest to the point A0. So A0 is other point, this on x-axis. Now xy be the point on parabola ds, okay, which is nearest to this. Therefore, distance between these two be s. So s square, s distance between xy and P, here A0, is equal to x minus a whole square plus y square. And from this relation, 2y dy dx is equal to 2p. So dy dx is equal to p by y. Now 2s ds dx is equal to 2x minus a plus 2y dy dx. That is equal to 2x minus a plus y into p by y. At critical point ds dx 0, when ds dx is equal to 0, that should be 0. X minus a plus p is equal to 0. X is equal to a minus p. Now d2x dx square. Again, the relation is s into ds dx is equal to x minus a plus p. S dash into s dash, this is ds dx is equal to s dash square plus s into s double dash is equal to 1. This is greater than 0 when x is equal to a minus p, because if we put x is equal to a minus p, this becomes 0 and s always positive. So this, therefore s is minimum at x is equal to a minus p. Divide 5 into 2 parts. So one part is x, another part is 5 minus x, such that product of the square of one and cube of other may be the greatest possible. So y is equal to this. Y dash is equal to 2x into x 5 minus x whole cube plus 3 into 5 minus x into minus x square into minus 1 by differentiating this into x square. So if you take 5 minus x square and x is common, then we have 2 into 5 minus x from this part minus 3x. Ten minus 5x. Five minus x whole square x 2 minus x. Now x is y dash is equal to 0 at x is equal to 5, x is equal to 0 and x is equal to 2. Actually, if y also 0 at these 2 points, this and this, and y double dash that also 0 at x is equal to 5, because there will be a factor of this. So we should check this value at x is equal to 2. Double dash is equal to 5. When we differentiate this, 2 into 5 minus x into minus 1 and remaining constant plus. Next this 5 minus x whole square into 1 into 2 minus x plus, and this 5 minus x whole square into x into minus 1. Now directly we put x is equal to 2, then we will get f w dash 2 is equal to 2 into, that is 3 into minus 1 into 2 into 0. 0. Only this becomes 0. Okay. Plus this 5 minus 2, 3, 9 and minus 2. So minus 18, less than 0. Less than 0, that is maxima. So it will give maximum value at x is equal to 2. Get as possible. So x is equal to 2 and y is equal to 3. Another 2 part, 2 and 3. Using calculus, find the length of the perpendicular from point atho upon this. So perpendicular is the shortest distance between the point and a point on the straight line. So let xy be the xy be any point on 3x minus 4y plus 5 is equal to 0. Then distance between xy and 2 minus 1 is d square is equal to x minus 2 whole square plus y plus 1 whole square. This is the relation. Now first differentiating this part, 3 minus 4 dy dx is equal to 0. dy dx is equal to 3 by 4. Now this 2d dd dx is equal to 2x minus 2 plus 2y plus 1 dy dx is equal to 2x minus 4 plus 2y plus 2 into 3 by 4. Now at critical point, dd dx will be 0, and if it is 0 then whole will be 0. So when d dx is equal to 0 at critical point, therefore 2x minus 4 plus y plus 1 into 3 by 2 is equal to 0. 4x minus 8 plus y plus 1 is equal to 0. 4x plus y is equal to 7. Oh yes, 3. 3 by 3. So 4x plus 3y minus 5 is equal to 0. Now solving these two, 3x minus 4y plus 5 is equal to 0. X by 15 minus 20, y by minus 15 minus 20 is equal to 1 by minus 16 minus 9. X is equal to minus 5 by minus 25, 1 by 5, and y is equal to 1. Minus 25, no, minus 35. Minus 35 by minus 25 is equal to 7 by 5. So these are the coordinates of the point on straight line which is nearest to the given point. Okay. Now differentiating this, d dx whole square plus d into d2d dx square is equal to 2 plus 3 by 4 into 2 dy dx is equal to 2 plus 3 by 2 value of dy dx 3 by 4. At x is equal to given value, that is 1 by 5, it will be positive, and this becomes 0 and it will be positive. So we can say that it will be a minimum when x is equal to 1 by 5. Now use calculus for the length of the perpendicular. So d length of the perpendicular is equal to x minus 2 whole square plus y plus 1 whole square root over is equal to root over 1 by 5 minus 2 whole square plus 7 by 5 plus 1 whole square, and after calculating this you will get the value. F dash x is equal to 12x square plus 2ax plus b, and f double dash x is equal to 24x plus 2a. It has an extremum at x is equal to 2 and minus 2. So we can say that if you put x is equal to 2, then we will get fx is equal to minus 2. 8 into 4, 32 plus 4a square plus 2b sorry, 4a plus 2 is equal to minus 2. So 36. 2a plus b is equal to minus 18. This is equation number 1. And f dash 2 is equal to 0. Because one of the critical points it is. So 12 into 4 plus 2a into 2, 4a plus b is equal to 0. So 4a plus b is equal to minus 48. Equation number 2. 4a minus 2a, 2a is equal to plus 18 minus 30. A is equal to minus 15. And b is equal to minus 30 plus b is equal to minus 18. B is equal to 12. So a is equal to minus 15 and b is equal to 12. So fx is equal to 4x cube minus 15x square plus 12x plus 2, and f dash x is equal to 12x minus 30x squared 30x plus 12. Okay. Six 2x square minus 5x plus 2, 6 Okay. So we have two critical points. One, x is equal to half, another 2. Now f double dash x is equal to 6 into 4x minus 5. F double dash 2 is equal to 6 into 8 minus 5 less than 0. This is minimum, maximum. And f double dash half is equal to 6 2 minus 5, that is less P is equal to price per unit, and Q is equal to quantity. Therefore, revenue function price into Q, P into Q. So P is equal to 100 by Q plus 2 into Q. The marginal revenue হচ্ছে dr dq is equal to the marginal revenue q plus 2 whole square differentiation of q is 1, so q plus 2 minus q minus 2 by q plus 2 whole square. That is the marginal revenue. That is 200 divided by q plus 2 whole square.